And I should be live right now. Why is my webcam not working? That's a new one. Did I unplug it? And it works. Okay. So welcome to day 7 already. We're over halfway. It already started. I'm still setting up. I had some trouble with the kids, but normally they should be behaving nicely. Except for the small one. The small one is already coming. Okay, I'll quickly set up my phone thing so I can actually like follow the chats. Voila, I have my Twitch open. Now YouTube as well. Let's see. The internet here is rather slow today, so I don't know how well the stream will work today. Okay. They both are here right now, though. So yeah, this will be a nice stream. This will be a stream full of concentration. Say hello. He's just awake. He just woke up. Okay. Let's go to today's challenge. So this is yesterday's challenge. I did optimize my code a little bit for day 6. So if I go in here, I started choosing a function called reduce that is available on arrays, which is kind of helpful. Because that way I can easily do like times 90 and plus 90. So yeah, it became a little bit cleaner and it also became faster. So now, so now the first one, part 1, runs at 1 millisecond, second one at 5, sometimes 4. It really depends on the mood. Yeah. Anyway, let's reset this number so we actually get the correct day. Normally this should say day 7 now. Yep. And let's start with part 1. Also, let's quickly change this. So, laboratories. Do you think that word again? First of all, does my audio work? Let's quickly check that. Yes, I see something move. Let's quickly do this. Yep, that moves. Okay. Oh yeah, I'm Twitch affiliate now, so if you're watching on Twitch, you're probably going to get advertisements every now and then. I did set it to a small amount, so yeah, let's hope that does not bother people too much. Okay, anyway, story. You thank the, what was it again? The octopuses for, octopi? Squids for the help and exit the trash compactor, finding yourself in the familiar halls of a North Pole research wing. Based on the large sign that says teleporter hub, they seem to be researching teleportation. You can't help but try it for yourself and step onto the large yellow teleporter pad. Suddenly, you find yourself in an unfamiliar room. The room has no doors. The only way out is the teleporter. Unfortunately, the teleporter seems to be leaking magic smoke. And my kids are already doing a good job in the background. Since this is a teleporter lab, there are lots of spare parts, manuals, and diagnostics equipment laying around. After connecting one of the diagnostics tools, it helpfully displays error codes 08-N0, which apparently means that there's an issue with one of the tachyon manifolds. Okay. You quickly locate a diagram of the tachyon manifold, your puzzle input. A tachyon beam enters the manifold at the location marked S. Tachyon beams always move downwards. Tachyon beams pass freely through empty spaces, dots. However, if a tachyon beam encounters a splitter, the beam is stopped. Instead, a new tachyon beam continues from the immediate left and from the immediate right of the splitter. Okay. Yeah, this seems doable. Okay, so this process continues until all the touchdown beams reach a splitter or exit the manifold. To repair the teleporter, you need to understand the beam splitting properties of the touchdown manifold. In this example, a touchdown beam is split a total of 21 times. Analyze your manifold diagram. How many times will the beam be split? Um, okay, great. Okay, so it does not look too difficult, but let's see how big of a mess my head makes it. So test data, let's get the real data as well. Where is the test input? Okay, so basically one giant Christmas tree. I I wonder. Hmm. I've hmm. Can we just huh? I kind of wonder if we can just count all the dots on the bottom and that will be the answer. Because it does look very plausible that that is actually like going to be the correct answer. Um, let's try it. Var data is a packed string array. Data dot get string array. Data path, and then we return the data minus 2 dot count dots. Okay, this will most likely be wrong. This prints 9. Oh no, we also need to count how many times it splits. Okay, so the touch beam is split a total of 21 times. So okay, no, we actually need to count. I thought we only need to count like the ending. Okay, so no. Okay, okay, some boilerplate out of the way.
Yeah. Like that.
So for the test data, wait, we're using the test data, right? Yep. So I start at the S. And we only need to count, okay. There's always an empty row in between each of them. So we can probably skip some of the calculations by just ignoring each second row. So for I int in data dot size minus 1. Wait, how many lines are there in total? 1, 4, 2. And minus 2 because we don't need the top and the bottom line, I guess. Divided by 2. And we print data I. Let's see if it that we get the correct lines or not. Nope, not exactly. Um. Oh wait. Um. Let's see. Okay. Let's remove this one. Okay, so now we get all the correct lines. So so with this we go over each line. We start at S. So first up, we do need to do 2 plus because we don't need to S. Wait, there are 3 on the bottom. Is that correct for the test data? Oh wait, we're missing like a lot of them. Okay, baby chit, you go away. Okay, so like this, we do get 1, 2, 3, 4, 5, 6 lines. 1, 2, 3, 4, 5, 6. So we're still missing 1. Okay, so 1, 2, 3, 4, 5, 6, 7. Okay, so now we get the 7 lines, and there are 1, 2, 3, 4, 5, 6, 7. Okay, so now we get all the lines. We got all the lines that actually matter. So var line is a string, and we just got this one. And integer division. Unused variable. Okay, that does not matter. Okay. So we get the data that we need. We do need the start points. Var splitters hit equals to 0. Oh no, we can just do answers for that, but we need to keep track of where each beam is. The problem is if some of them merge with each other, like here, does that count? At this point, two splits create a total of 3 beams. This process continues until all of the beams are split 21 times. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 20. Oh. No. So if they get merged, it does not count as a split anymore. Right, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Wait a minute. I can't even like wrap my head around the example right now. Oh. So over here it splits twice. 5, 6. Oh no, only the ones that the times that we hit it. Okay, so 1, 2, 3, 4. I count 22. Oh no, this one never gets hit. Okay. So 20. Okay, so we don't need to count the amount of beams. We just need to count the amount of times that something gets hit. Okay. So var beams, which is a let's just back into array. Oh, let's just do an array. And for the first beam, we take data 1 dot find s. So for beam, this is an int inside of a beams. If line, oops, beam equals a splitter, whoops, wait, what character is it? Okay. If we hit that, our answers 0 goes up by 1. And our beam gets removed. For new beams is an array. New beams become, else we add the beam back to the array. New beams dot append beam, and else beam minus 1 and beam plus 1 gets added. And then beams equals new beams. So this okay, so this should print 21. Beams. It's minus 1. Oh, wait, yeah, no. Okay, so this will work. So we have our 12. Beams is found on 7. No. 0, 1, 2, 3, 4, 5, 6, 7. Yeah. Beams line. Oh. I think I will need to do something about my kit first. I'll be right back. Okay, what I will do, I'll print a visualization, because else I think I will start getting into issues. So, for I int in line dot size length, print wait, for lines is a packed string array. This is the first time that I actually like write specific code for visualization during advent of code this year. Last year I used to do that a couple of times, but I have not been doing it at all. So for I in line lengths. Oh, let's just call this new line. And it should just be a string, I guess. If I in beams. Oh, and there's a package delivery. It does seem like I'll be interrupted the entire day. So yeah, this is a good beginning. So where was I? It's always every single time when I get distracted, it's like kind of adjusting to get back into it. Wait, why is this an error? Okay. X new line, we add a beam. Else we add a new line plus equals line X. And now you print a new line. So where is it going? It is not going wrong. Wait. 1, 1, 2. Eh? Okay, so I'm not getting the correct line. I'm not getting the correct line. Wait, what is this print? Two, 4, 4, 6, 6, 8. Okay. Hmm. How can I do I do times 2? I So 2, 4. Okay, I just did that. I tried to do it too complicated. Now it's 39. Hmm. Now let's go here. Let's quickly copy paste this one as well. We don't need this one. We don't need this one. We don't need this one. Oh, yeah. So we have 2. Oh, okay, I think I know what's going wrong. We're getting duplicates. That's the issue right now. So as soon as we get rid of the duplicates, then everything will be okie dokie. So new beams. Ta 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 ta. How do we do this like efficiently? Is it like a slice clear maximum hash back sort? Oh, and I'll be BRB again. They're turning on the air conditioning. And I'm back again. Okay. So, else alif new beams dot has beam, and if it does not have, then we append it. I guess I just have to check if it already exists or not. New beams dot has beam -1. Append. Okay, not the best looking code, but will probably work. I don't know if there's an easier way to get all the things out. Or I can just do this. Beams equals an empty array. And for no, it's just I need to do my if statements back. Okay. That has b -1. This will be 21. Why is it? Oh wait, yeah, no. beams equals new beams. That's fine. 21. Okay. And that's this. And let's get our normal data. Pum, 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 pum. Let's run. 1635. So let's submit this. That's right. That's the right answer. You're 1 gold star closer to decorating the North Pole. I'm getting faster. Okay, part 2. With your analysis of the manifold complete, you begin fixing the teleporter. However, as you open the side of the teleporter to replace the broken manifold, you are surprised to discover that it isn't a classical tachyon manifold. It's a quantum tachyon manifold. With a quantum tachyon manifold, only a single tachyon particle is sent through the manifold. A tachyon particle takes both the left and the right path of each splitter and countered. Since this is impossible, the manual recommends the manual's interpretation of quantum tachyon splitting. Each time a particle reaches a splitter, it's actually time itself which splits. In one timeline, the particle went left, and in the other timeline, the particle went right. To fix the manifold, what you really need to know is the number of timelines active after a single particle completes all of its possible journeys through the manifold. Okay, so I is it me or is the part 2 looking surprisingly simple today? Return answers. Oh. Answers 2. So basically the solution that I had before is basic. It is the correct one. So if I just do this and this. Oh. 58. Out of bounds, get index 2. Also, wait, each splitter will oh, whoops. Each splitter will create 2 new timelines. So we just add 2 for each time that it reaches a splitter, and we start at 1. So oh no, we start at 0. Well, let's start at 0 first. Let's also copy this debug code because something is going strange. Wait, at 58. Oh wait, yeah, no, it's just my own dumb faults. Oh, we got 78. So that's not correct. As it is. That's 39. We should get 40. So we start with one timeline and we create a second one. So we start at 1. So that becomes 40. And if I go to the main data then, I think I may have finished already for today. Of course, it's an optimization thing again. Of course, it's an optimization thing again. Yeah. No worries. I think I have a good idea. We create a dictionary instead. Wait, let's first see. I kind of want to know how long this actually take per round. So print try. Okay, so this gets gradually slower and slower, starting from 40 lines already. Okay, so my second idea to optimize this is we create a dictionary instead. This becomes a 1. So we don't create a new beams array. We do this. If it splits, then beams beam equals 0 and beams gets added. And then beams, wait. Of course, it could not be as simple as I thought it will be. So we set a beam. We add this. We don't need to do this anymore. And this one also does not need to do anything anymore. Wait, why are we, because of the new beams? Okay. Let's first see with test data if this still works somewhat correctly. Oh, wait, yeah, no. Okay. We should reset that to 0 later. Okay. So this should be... It should be 40. Beams dot... I don't want to remove anything because I feel like we will probably go over the same number. So instead of having to recreate a new value each time, we can just do it, well, in the same value that already exists. Instead of that, well, this debug print won't work anymore, so we could var count int equals 0 for beam int in beams. We whoops, count plus equals, and we add beams beam amounts. Okay, that makes sense at this moment. So var count 0, and then just print counts. So we start that we split by 2, ping pong. Wait, let's say test code again. So we have to, this should be 4. That should not be 3, that should be 4. Why is this 3? Oh, wait. Yeah, no. We need to do plus. Oh, whoops. Plus. Okay. Okay, I think I got it. Oh, whoops. This will print 40. And, oh. If beams has beam -1, then we just created beams. Beam -1 equals 0. And over here, we do the exact same thing. And this will print 40. Okay, and now the real test. Is this efficient enough? 4 milliseconds. Let's see if it's correct. I hope it is correct. I think it is correct. That's the right answer. You are 1 gold star closer to decorating the North Pole. You have completed day 7. So I'm already done for today. The chat was very empty, probably because of the time that I'm streaming, because yeah, this time it's convenient for me because it's afternoon, but in both Europe it's very early morning, and in America it's night right now. So yeah, that's unfortunate. But anyway, for the 3 people who are watching on YouTube, there were people watching on Twitch. There are also 3 viewers, so thanks for watching, and yeah, I guess I'll see you tomorrow with day 8. Oh, did I show my screen? Yeah. Oh, does this actually work? Like, I tried to do the whole vertical streaming thing, but I don't think this is very easy. Yeah, I will probably start disabling that. That it's really not worth to look at that kind of a screen. But yeah, anyway, thank you for watching, and I'll see you all in tomorrow's stream. Bye-bye. This was a very easy one. I'm still quite surprised with how easy this was. Like, how can it be that simple? I optimized it so well that it takes the same amount as part 1. Like, can I do any like improvements to this? I feel like maybe I can do for I int data 0 dot size. I can probably do this beams I equals 0, and then whoops, and then beams not beams is data 0 dot find s. I will just set this to 1. Can I find member size? Oh no, it's lengths. It's lengths. Oh. Okay, can we increase this by like a millisecond? Oh. I should probably press play. Okay, it does take longer now. But that's because I still have these here. These if statements. With these if statements gone, it takes 1 millisecond longer. 2. Oh, okay, now it's 8. How is it possible that I directly had like the most efficient way of doing this? Like, how is that? I feel like I did something wrong. I feel like I'm still even like am I print? Yeah, I'm still printing these. So well, I guess I'm just getting too good. I was not showing my screen, but anyway, yeah, I got it working now. So yeah, I guess that's the end of the stream. Thanks for watching, and I'll see you all next time. Bye bye. Also, a big thank you to all my co-supporters. Thank you very much, and yeah, See you tomorrow.